Premiering this year, an EO event unlike anything you've ever seen. A 4-part mini-series of triumph, of love, of science, and of optics. Your future children will ask you where you were for the premiere of Soliloquy of the Censor.
Hello everyone, I'm Chris, a machine vision sales engineer here at Edmund Optics, and this is Byte Size. This season, Byte Size will conquer the concepts behind how sensors and optics interact in a year-long 4-part series. Sensor nomenclature and lens coverage, focal length and magnification, resolution, and finally, pixel size. By the end of this season, you'll be able to determine the most cost-effective system for your application. So let's kick it off with sensor nomenclature and lens coverage. For this particular camera, our sensor has 3.45 micron square pixels. By knowing the size of our pixels and our array size, we can calculate our sensor dimensions to be 8.4 millimeters long by 7.1 millimeters tall. Then, by using our friend the Pythagorean theorem, we get our sensor diagonal to be 11 millimeters. This sensor is categorized as the common 2/3 inch sensor format. You math-minded cadets are asking, Chris, 2/3 of an inch is 16.933333333, repeating of course, millimeters. And that number doesn't show up anywhere on that sensor. I'll reply, great catch, cadet. Unfortunately, in Sensorland, the math is made up and an inch is 16 millimeters. This means that our 11 millimeter sensor is a 2/3 inch sensor format. Why is this the case? Analog tubes. You see, when digital sensors first arrived on the scene, it was discovered that 11 millimeter diagonal chip was the equivalent to a 2/3 inch diameter analog tube. From this point on, the pioneers referred to digital chips to their equivalent in analog tubes. While analog tubes are no longer relevant, the naming convention stuck. While the aspect ratio of a sensor may change, the diagonal of our 2/3 inch sensor will almost always be 11 millimeters, except when it's not. Now, why do we refer to it as diagonal? Our chips are always rectangular, while imaging lenses produce images in what is referred to as image circles. Because the diagonal of our chip will always be our longest measurement, this tells us the minimum image circle our lens must have to cover our sensor, lest we vignette. Thanks to the success of Byte Size Season 1, we've been able to assemble a team of engineers and experts to simulate what vignetting would look like on your screen. Those of you at home can see the dark parts around the edges of your screen, or our vignetting. This means our lens is not appropriately sized to utilize all of the pixels on our sensor. But you paid for those pixels and gosh darn it, we're gonna make sure you can use them. Let's pop over to the lab, see this in action. Welcome to the lab. Here's our camera from earlier, a 2/3 inch sensor format with an 11 millimeter diagonal. We also have 3 different 8 millimeter focal length lenses, each designed for different size sensors. I'm sure you notice how much larger the lenses grow, which means significantly more glass and metal, which means more expensive to produce and ultimately buy. This is our 8 millimeter Blue Series lens. It's designed to cover the 1/3 inch sensor format, which is a 6 millimeter diagonal, significantly smaller than the 11 millimeter diagonal of our sensor. Now let's throw this puppy on there and see how it looks. Look at those wasted pixels. This lens is not nearly large enough to cover the full sensor. Here, we have the 8.5 millimeter HR series lens, designed specifically with the 2/3 inch sensor in mind. Let's throw this dog on there. Eureka! It's perfect! This lens collects enough light to fully cover our sensor. No vignetting. And now for the third lens. This is our 8 millimeter HP series lens, which is designed for the 1.1 inch sensor or the 17.5 millimeter diagonal, meaning it's significantly larger than our camera's sensor. Now let's throw this hound on there. Don't really see a difference in our image compared to the previous lens. Our imaging sensor is still covered, but I'll let you in on a secret. From the perspective of sensor coverage, the last two lenses perform nearly identically, but this bigger one costs significantly more. Though we haven't delved into the performance of these lenses, we will in a later episode. So make sure you specify an appropriately sized lens for your application when you're looking for a lens. As Grandma always said, when it comes to the world of machine vision, everything is application dependent. So in summary, if you have a large sensor, use a larger lens. But if you have a smaller sensor, make sure you've selected a lens that matches your sensor size. Now that we've covered coverage, next video will focus on focal length and zoom in on magnification to help you make more informed decisions. Thanks, cadets, for traversing the optical space with me today. If you have any questions, reach out at edmondoptics.com. We have real live engineers available 24/7 to address your imaging needs. As always, I'm Chris Razzie, and this has been Byte Size. For a more handsome but less exciting explanation that goes more into the weeds, check out our lab series.